Hey guys, Shot here with another video. This is part of my AI teaching series. In this video, I'm going to teach how to fine-tune an LLM, aka how to fine-tune an AI model, pretty much how to fine-tune one of ChatGPT's models. And I'll explain what fine-tuning is in a second, but please watch my first and second video in this series so you know what this series is about and how I teach in this series. But essentially, let's kind of hop into it, you guys. So in this video, I'm going to explain what fine-tuning is. I'm going to show you the code to do it. I'm going to do it in both Google Colab and I'm going to do it in PyCharm. And I'm going to break down the code step by step, what's going on essentially. And then in the later videos, I'll go into even more detail on how everything works and stuff like that. I just want you guys to start doing cool stuff right away so that you're very encouraged to keep on going and excited to keep learning instead of doing the boring stuff in the beginning and then do the cool stuff. I give you the cool stuff in the beginning so that the boring stuff is even more fun to you. It's a really effective teaching technique. So let's get into it. What is fine tuning? I should probably name this file fine tuning. Fine tuning diagram. How do you spell diagram? That is crazy. Cool. Okay, so here's what fine tuning is: pretty much teaching a already trained model a little bit more information that's similar to what it already knows. So let me explain. So imagine you have two brains, aka two people. You have a newborn baby and you have a master cooking chef. And the goal is you want this AI model to bake an Egyptian cake, right? So we got two different models. Let's say we get a model, we make it from scratch. That means from ground zero, we're training it from scratch. That's the equivalent of getting a newborn baby, raising it for 16 years, spending 100K raising that child because children are not cheap, and then the 16-year-old will be able to bake an Egyptian cake. Now, let's say you grab a master cooking chef. They already been training for years. You grab this person, you show them for 1 hour how to make the Egyptian cake because they're already a master chef, so they can pick up on it. They can learn quicker the subject of like baking a cake. You spend $30 for their time, maybe $50 for their time, and then they can bake the Egyptian cake. This situation is fine tuning. This right here on the left, it's not even aligned. That's gonna bother me. This on the left is what training an LLM by yourself from scratch looks like, right? 16 years. That's probably like 18 hours or 14 days of training this thing for it to do what you want, and that's training it from scratch. Like, it's creating your own ChatGPT from scratch. But this one is grabbing a model like ChatGPT, and then you teach it a little bit for like a couple minutes or an hour, and then it should be able to do the test that you want it to do, right? So this is why fine-tuning is so powerful for people that don't have the money and energy and whatever to just make their own ChatGPT. It's very energy intensive, very computer intensive, and this is simple. Right, so this is what fine-tuning is. Fine-tuning is pretty much getting a model that can do something, show it something similar, and it can do that as well, right? So, but let's say it was to fix a car. Fix a car. So if I wanted a AI model let's say the AI model, it's trained on its cooking, and I wanted to fix a car, it's probably not going to be able to know how to fix a car because it's way different than cooking. Fixing a car and cooking is very different. But let's say I wanted it to tell me what's healthy. This is actually something that it can do because cooking and what is healthy are similar subjects, so it'll be able to understand it. So the closer the new thing is you want it to do, the better it's going to be at doing that thing, right? So I'm gonna play this video for you guys, and then we're gonna hop into some code. Yeah.
Hey everyone, I'm Shah, and this is the 5th video in the larger series on how to use large language models in practice. In the previous video, we talked about prompt engineering, which is concerned with using large language models out of the box. While prompt engineering is a very powerful approach and can handle a lot of LLM use cases in practice, for some applications, prompt engineering just doesn't cut it. And for those cases, we can go one step further and fine-tune an existing large language model for a specific use case. So an obvious question is, what is model fine-tuning? The way I like to define it is taking a pre-trained model and training at least one internal model parameter. And here I mean the internal weights or biases inside the neural network. What this typically
Pretty much models have a brain, right? And it is the brain. Like as a person, you have a bias and you have some weights and situations, right? So a bias is you might on a Friday night you might want to go watch a movie instead of going hiking, right? That's your bias if you have free time. A weight can be like, let's say you're 6 feet tall versus 5 feet tall. How you decide to fight a bear will be different, right? Maybe if you're 6 feet tall and the bear is only 4 feet tall, you might fight the bear. But if you're 5 feet tall and the bear's 4 feet tall, you might run away. So that affects the situation. So that's pretty much how these neural networks work, aka the models work, aka how ChatGPT works. Just weight and biases that is inside of it, and when you're fine tuning, you're gonna modify these a little bit.
Typically looks like is taking a pre-trained existing model like GPT-3 and fine-tuning it for a particular use case. For example, ChatGPT. To use an analogy here, GPT-3 is like a raw diamond right out of the earth. It's a diamond, but it's a bit rough around the edges. Fine-tuning is taking this raw diamond and transforming it into something a bit more practical, something that you can put on a diamond ring, for example. So the process of taking the raw base model of GPT-3 and transforming it into the fine-tuned model of GPT 3.5 Turbo, for example, is what gives us applications like ChatGPT or any of the other incredible applications of large language models we're seeing these days. To get a more concrete sense of the difference between a base model like GPT-3 and a fine-tuned model, let's look at this particular example. We have to keep in mind that these foundation large language models like GPT-3, Llama 2, or whatever your favorite large language model is, these models are strictly trained to do word prediction, given a sequence of words predicting the next word. So when you train one of these large language models on huge corpus of text and documents and web pages, what it essentially becomes is a document completer. What that translates to in practice is if you plug into a lot of these base models like GPT-3, the prompt, tell me how to fine tune a model, a typical completion might look something like this, where it's just listing out questions like you might see in a Google search or maybe like a homework assignment or something. Here, when I prompted GPT-3 to tell me how to fine tune a model, the completion was as follows. How can I control the complexity of a model? GPT typical. Now let's look at the fine-tuned model completion. So now we have Text DaVinci 003, which is just one of the many fine-tuned models based on GPT-3 coming from OpenAI. We give it the same prompt, tell me how to fine-tune a model, and this is the completion. Fine-tuning a model involves adjusting the parameters of a pre-trained model in order to make it better suited for a given task. There are generally 3 steps involved to fine-tuning a model. Select a base model, adjust parameters to get out of the language model compared to the base model's completion. So if you want to learn more about model fine-tuning and how OpenAI did their fine-tuning, their alignment tuning and instruction tuning, check out the references in the description and comment section below. So as we saw, when comparing a base model to a fine-tuned model, we see that the fine-tuned model can generate completions that are much more aligned and desirable for our particular use case. Beyond this performance, there's actually a deeper reason why you might want to fine-tune, and that is the observation that a smaller fine-tuned model can often outperform a larger base model. This was demonstrated by OpenAI.
Pretty much fine-tuned models, if you compare a fine-tuned model compared to a out-the-box ChatGPT model that's not fine-tuned and you make it do the same task, most likely the fine-tuned model will do the task way better because, sorry, there's a bug in my face, because that smaller model or the fine-tuned model is specialized, right? When you have a base model, it's just very general, right? Like you would like kind of like if you go to your dad to fix your car versus you go to a mechanic to fix your car, both of them will fix the car, but the one that will outperform is the specialist, aka the mechanic will outperform your dad on fixing the car because they are more fine-tuned and the dad is more of a generalist. You know, your dad can cook, clean, be a great dad, do sports, he can drive, but the mechanic can only do one thing: fix cars. He can't cook, he can't clean, he can't be a good dad for you, but he's really specialized on just fixing cars, which will outperform the generalist, right? That's what it's trying to say.
in their Instruct GPT model, where their small 1.3 billion parameter fine-tuned Instruct GPT model generated completions that were preferred to GPT-3 completions, even though GPT-3 had about 100 times as many internal parameters. This is one of the biggest upsides of fine-tuning. You don't have to rely on some massive general purpose large language model to have good performance in a particular use case or application.
What the 1.3 billion means and the 175 billion means is that this model has more information that it knows than this model. Like this one knows how to cook, clean, it knows how to make wood, it knows how to chop trees, it knows how to make. I'm trying not to say crazy stuff. It knows how to make crystals, it knows how to fly, it knows how to do your homework. This one knows only how to fix cars. Which one you think is going to do better at fixing cars? This one. Even though it knows less, it knows only about fixing car stuff, it will do better than the one that knows a bunch of other stuff that's kind of pointless to the task, right? That's what it's trying to say.
Application. Now that we have a better understanding of what fine-tuning is and why it's so great, let's look at 3 possible ways one can fine-tune an existing large language model. The first is via self-supervised learning. This is the same way these base models and foundation large language models are trained. So in other words, you get your training corpus of text and you train the model in a self-supervised way. In other words, you take a sequence of text like listen to your, you feed it into the model, and you have it predict a completion. If we feed in listen to your, it might spit out heart. What would differentiate fine-tuning with self-supervised learning versus just training a base model through self-supervised learning is that you can curate your training corpus to align with whatever application.
I'm going to just skip ahead because this training method I wouldn't recommend for people learning right now what they're doing. This is for people that are more advanced, that are super deep in like the PhD space if they want to fine-tune a model. I'm going to skip ahead to the actual method that beginners and regular people and just AI engineers in general should probably train their models so they have control over what it's learning. I'm going to skip to that.
This is output. We more like my style. The second way we can fine-tune a model is via supervised learning. This is where we have a training data set consisting of inputs and associated outputs or targets. For example, if we have a set of question-answer pairs, such as who was the 35th president of the United States, and then the answer is John F. Kennedy.
So input means question or command, output means the response or the answer to the question or command. Or like maybe it's like a sequence of things that it needs to do based on a command. That's what input output means.
We can use this question-answer pair to fine-tune an existing model to learn how to better answer questions. So the reason this might be helpful, as we saw before, if we were to just feed in who was the 35th president of the United States into a base model, the completion that it might generate is who was the 36th president of the United States, who was the 40th president of the United States, who is the Speaker of the House, so on and so forth. But through having these question-answer pairs, we can fine-tune the model to essentially learn how to answer questions. But there's a little trick here. These language models are, again, document completers. So we actually have to massage these input-output pairs a bit before we can feed it into our large language model for training. One simple way we can do this is via prompt templates. For example, we could generate a template, please answer the following question, where we input the question here. So our input would go here, and then we input the target here, so the answer.
Pretty much what he's trying to say is, so I'm gonna show you guys this method. I'm gonna fine tune a model live here, like myself, using this method because it's the one I've used at work, and for a lot of different other projects that I've done. Pretty much, he's saying that before you train a model on data, you have to prepare it, right? So imagine you wake up at 6 in the morning, and the first thing you see is me in a suit talking about, all right, you ready to learn this thing, and start teaching you, but your brain's not ready yet to learn anything. You just woke up, right? I got to prepare you. Or imagine it's like, oh, it's a training day. Instead of warming up and stretching, you just start running, right? And you're going to get injured most likely, right? So it's like preparing the brain to learn. Or you tell it what you're going to do today. So it's kind of like, hey guys, in this video, you're going to learn question and answers. Cool. So now when I show you something, you learn it a lot better versus like, I start the video, you just see me coding, and I just show you something, right? It's not an effective way to learn. These models emulate or copy how our brains actually learn in real life. So the better you understand your brain, the more you understand these models as well. But they're not alive and they're not real people, okay? Let me just specify that.
would go here. And then through this process, we can translate our training data set to a set of prompts and generate a training corpus, and then go back to the self-supervised approach. And the final way one can fine-tune an existing model is via reinforcement learning. While there are many ways one could do this, I'm going to just focus on the
Reinforcement learning is very similar to the idea of how you raise children, right? Usually if a kid does something bad, you tell them that's bad, right? If they do something good, you say, oh, that's good. And the kid most likely is going to keep doing good things unless it's a rebel. But let's assume that kids have the innate nature to do good, right? If you tell a kid, oh, drinking water is good, it's most likely going to keep drinking water. Now, if he drinks 3 bottles of water in 2 minutes, you'd be like, no, that's bad. And it's like, oh, I can drink 1 bottle, that's good. 3 bottles is too much. Cool, cool, cool. So he understands what's too much, what's too little. By you just saying, that's good, that's bad. You didn't tell it, oh, 3 bottles is too much, 1 bottle is just enough. You just said it, you drinks one bottle. If it drink 1 water bottle, you're like, oh, that's good. It's like, okay, water's good. And if it drinks 3 in 1 minute, you're like, oh, that's bad. It's like, okay, I'm a little confused now, but I think it's the amount of water is the problem. Then they try 2, you say bad, and then when they drink 1 water bottle again, you say good. They're like, okay, 1's just the magic number to get good, right? It's kind of like how reinforcement learning works in a way.
Approach outlined by OpenAI in generating their Instruct GPT models, which consisted of 3 steps. The first was supervised fine-tuning. So essentially what we were talking about in this second way to fine-tune a model. This consists of 2 steps. 1, curating your training data set, and then 2, fine-tuning the model. The next step was to train a reward model. And all this is essentially a model that can generate a score for a language model's completion. So if it generates a good completion, it'll have a high score. If it generates a bad completion, it'll generate a low score. So what this looked like for the Instruct GPT case was as follows. You start with a prompt and you pass it into your supervised fine-tuned model from here, but you don't just do it once. You actually do it many times. So you generate multiple completions for the same prompt. Then you get human labelers to rank the responses from worst to best, and then you can use that ranking to train the reward model, which is indicated by this square here. And then the final step is to do reinforcement learning with your favorite reinforcement learning algorithm. In the case of Instruct GPT, they used proximal policy optimization, or PPO for short. What this looks like is you take the prompt, you pass it into your supervised fine-tuned model, and then you pass that completion to the reward model. And then the reward model.
Okay, I'm explaining this very simple. Pretty much, the way they're talking about is that this reinforcement learning requires people to sit down and talk to the model. So the model it'll say something, and you pretty much say good or bad, or how good or how bad it is, by physically like talking to the model. So like talking to it for hours essentially, right? Which requires a lot of people, or a lot of one person doing this for hours essentially. Which is why this is not the best way to do it, but this does work too, and it's probably the best way to. It's really effective if you have time and the money to do this. It's really effective because you yourself can train it, but it's a lot of time and a lot of money. The best way to train models is the second one. This is the best way to train them if we respect the time and money, right? Most people use this method. Very few people use this method unless they're giant corporations. Cool. So I'm just gonna skip ahead.
Model will essentially give learning first generation. It could be binary tuning. Here I break that process down into 5 steps. First, choose your fine-tuning task. So this could be text summarization, it could be text generation, it could be binary classification, text classification, whatever it is you want to do. Next, you prepare your training data set. If you're trying to do text summarization, for example,
So the task we're gonna focus on for like the demo is the fine-tuning task I chose was telling me if a food is healthy or unhealthy. That's pretty much what I chose. And preparing training data set, pretty much normally it looks like, at first when you're doing it, you're probably gonna make a Excel sheet or a Google sheet and make it from scratch, and then from there you can make some code that can generate the data set too. So you can either do it manually, make the data set via like Excel, Google sheet, and then have ChatGPT make some more make some more data, where you do it all manual, or you can have code that using like NumPy and pandas to create a data set using code and stuff like that. So there's a lot of ways to make the data, but today we're going to use Google Sheets and Excel to make the data from scratch, just so you can see what's going on. Down the line in the series, I'll teach you how to make data with ChatGPT or with just code. Yeah.
You'd want to have input-output pairs of text and the desired summarization, and then you take those input-output pairs and generate a training corpus using prompt templates, for example. Next, you want to choose your base model. There are many foundation large language models out there.
The base model we're going to use is going to be GPT-2. GPT-2 is the base model we're going to use because it's small and fast to train.
Or there are many existing fine-tuned large language models out there, and you can choose either of these as your starting place. Next, we can fine-tune the model via supervised learning, and then finally, we evaluate model performance.
This fourth step is the code. So I'm gonna give y'all that code. Remember, check below the document, open the document, copy and paste it into Google Colab or PyCharm to run the code with me so you can see what I'm doing. But watch me first do it here, and then you'll know how to use it on your own, essentially, because it's gonna be 2 files. One file will be for training the model, and one file will be for using that model that you just trained to answer if food is healthy or unhealthy, right? So it's 2 different codes.
There's certainly a lot of details into each of them, and then finally we evaluate model performance.
This is pretty much grading the model, right? We're gonna give it like it's like when you're in school. Do you give them an A or a D on the test, right, or an F on the test? So you score them with like out of 100, like 65% means that they got like a D essentially, right, or maybe a C depending if you're in college. That's a curve. But yeah, the higher the number is to 90, the better the model's doing. If it's at 100, most likely that's sometimes seen as a bad thing. 95 is like the sweet spot. 95% accuracy is usually the sweet spot for most models. Like, it's doing really good, but you have to double check, is it actually doing good as well? You can't just trust that number and think it's doing really good. But yeah, that's just what evaluate model performance means.
There's certainly a lot of details into each of these steps, but here I'm just going to focus on step number 4, the fine-tuning the model with supervised learning. And here I want to talk about 3 different options we have when it comes to updating the model parameters. The first option is to retrain.
All right, so he's going to get nitty gritty, but I don't want to get nitty gritty with it because it's going to confuse you guys. I want to help y'all start learning. So pretty much I opened up a Google Sheet and I made this data, right? Also, I'll put in the video below, I'll add this file as well. It'll be a CSV file. So if you want to make your own file, I recommend you go to googlesheets.com, Google Sheets, or type in Google Sheets. I'm trying to make sure you guys don't see my login information. Yeah, you'll see something like this. Once you log into Google Sheets, you just make a new sheet, blank sheet, and you can put input, and then go to the right, hit output. If you don't know what I did, you can just click here, type in input, click here, type in output. Cool. And you can start typing like, what did I put in the other one? Wow, where'd my other one go? That's crazy. Oh, it's under this. I just minimized this. Yeah, see, baked chicken is healthy. Baked chicken is healthy. Frozen apples, healthy. Frozen strawberries, healthy. Steamed broccoli, healthy. So you can manually type this out to create your data set. Now, of course, if I scroll down below, you'll see unhealthy at some point. 1 second. Yeah, you'll see unhealthy now. Like fried chicken, unhealthy. Potato chips, unhealthy. Soda, unhealthy. Cool. And this is my data set pretty much. It's not that many rows. It's like 63 rows of data. So I need 62 rows because this first row doesn't count. So technically it's 62 rows of data and just 2 columns, right? So this is a table, okay? This is pretty much a data table, and I just named it healthy food, whatever. So to save this, I want you to have a Google Sheets or Excel. You can do this in Excel too. File. I'll hit download. I'll click CSV, and you'll see it download and whatever. Cool. And if you open up your Shigamajig, go to downloads, you should see it right here. I had it here earlier already, so don't worry about that. But yeah, I already have one from earlier. And if you have Mac, you know how to find it in Mac. I trust you Mac users. In Linux, I know you know where to find it. I'm not worried about you people at all. Cool. So we made our data set for teaching the AI or fine-tuning AI what foods are healthy, what foods are unhealthy, and it kind of picks up on the pattern now. So we're specializing the model now. Cool. So now you got to go to Google Colab, and there's 2 chunks of code. Now, don't freak out. Just copy the code and paste it. I'll explain in detail what each chunk of code does, and then later down in the series, I'll explain even more in detail what's going on, right? I want to slowly expose you guys to what's going on versus just try to teach everything little by little and it overwhelms you, okay? Let me show you the cool stuff first. So, the first file you should copy and paste into this. It's the one that it should look like this, right? If the first part looks like this, then you will have the right file, okay? This is the file we're working on right now. And then the second file, you'll paste it into another cell. So you're gonna, matter of fact, I'll show you guys from scratch. Google Colab, click this. I'll click on new notebook. You're gonna click code. So now you have 2 cells, okay? And then whatever, like that first code, I'm gonna hit Control A. I'm gonna hold Control, press C. It'll be in a notepad or note thing. I'll hold Control, press V. Code's there. And then for the second one, same idea. I'm gonna hold Control, press A. Hold Control, press C. And then click here, hold Control, and press V. Cool. That's pretty much how you gotta copy and paste it. So now I'm gonna close this. God, that's not what I want. And then, and then you're gonna name it whatever you wanna name it. When you name it, you wanna name only this part. You name all that. Don't change anything after that. And then the last thing you need to do is to upload that file. So you need to upload, click this. Make sure it looks like this. Like if it doesn't look like this when you first open it, keep clicking it until it looks like this. Then click this upload button and download that sheet up to it. Upload this sheet, the one that you created. And it's warning you that after you log out of this thing, it's not going to save the data onto it. You got to reload the data each time you run it on Google Colab. But in PyCharm, it'll be on your local PC, so it's not a problem. And it's there. And then what you're going to do is you're going to come here under 3 lines. Wow, I need some water. The 3 lines, hit copy path. You're going to find this code line right here called df. I got you guys. It's df equals pd.readcsv. Highlight this area and hit Control V to paste like your path into it. It should be the same as mine, honestly. It should be the same. It should be exactly this. But if it doesn't work for some reason or you named your thing differently, then it'll look different. But make sure it's .csv, all that stuff. Cool. Which means you have to make sure you download this. You download it as a CSV, okay? So back to this guy, and then now the code should work. This part you can ignore, but if you don't want to make a code file and you want to just use a built-in code data if you want to download or create, if you want to skip this whole step right here, making data, downloading stuff, doing all that jazz, you just want to run the code, I got you. Just, how do I explain this? Click at the end of this, hold Control, press the slash next to the shift key. So the slash this is so funny. Pretty sure it's /, right? Put that here. Or another way to do it is just put, pretty sure this works too. Yeah, cool. So an easier way to explain it for non-technical people is if you hold shift and press the number 3 and put this hashtag in front of it, this deactivates this. And then you'll come here in front of this and backspace twice. And an easier way is just to highlight the whole thing, to be honest with you. Up to here and do the Control /, and that should bring it back. You know which slash it is. It's a slash towards the bottom of the keyboard, okay? I actually always forget which one is forward, which one's backwards, but I'm pretty sure that's forward. Actually, no. This stays that. Yes, this stays. This doesn't do anything. This is the part you need to focus on. Yeah, this is just instructions for you guys. So you can use this instead if you would like, if you don't want to download anything and all that jazz. But I'm going to use the file that I downloaded. So I'm going to hold Control, press Z to undo all the stuff that I did. Hold Control, press, oh, wow. Okay, yeah. All right, cool. Cool, right? That's the only thing you really have to modify And then everything I'll explain in detail in a second. Okay, cool. Making sure that's up and running. And then for this one, after you train your model, you'll get like a path that looks like, one second. You'll get a path that looks like, so I'm trying to find it for you guys. Path there. Okay. The path you'll get a file that looks like this somewhere on the left, but I'll show you guys in a second. Okay. And then I don't think you don't have to change anything on this. This is already ready to go. After you train your model, you can just run this next cell and it should work just fine. Cool. And that's pretty much how you use it in Colab. For PyCharm, I'll do Google Colab first, and then I'll switch to PyCharm later. Cool. I'll do the same thing I did here, but in PyCharm. Cool. So let me already have the one I set up. So what's gonna happen is, in that first cell, right? Now you uploaded all your data. You're gonna click this. I'm gonna actually hit X on this. Actually, no, click this. Cool. I'm gonna hit the play. And what's gonna happen is when you scroll to the bottom of this cell, you're gonna see some stuff happening, right? You're gonna see all this stuff happening. In the bottom right, you'll see executing happening. So you gotta wait until this is done executing, and it's just doing its thing. So it's gonna start downloading a bunch of stuff if you don't already have it, and then it's gonna start fine-tuning the model. This code is fine-tuning the model right now as we speak. You are officially fine-tuning a LLM, specifically GPT. And I'm gonna let it train. I'm gonna pause and come back when it's done. I'm just unpausing to show you guys like the in progress, right? Just so y'all can see if our screens are matching. Now, if your screen looks different than mine, Google Colab might have done an update by the time you're watching this, so keep that in mind too. If you're in the year 2027 watching this, it's probably gonna look a little different than mine because it's the year 2025 right now. But I'm gonna let it finish out fine-tuning the model. Now, a better idea is as this is training. Yeah, it's still fine-tuning. Yeah, it'll let you know when it's done at the bottom. So, in the meantime, I'm gonna walk through with you guys step by step what's going on. So first, this line of code, the pip stuff, is so this green stuff is pretty much like instructions and notes. Like if I write anything here, and I just write a bunch of, it does nothing to the code. It's just notes for you to read. Okay, I put notes for you guys. No, thank you. I don't need that. So this right here downloads everything you need to use. So it's kind of like ordering your tools before you start working on fixing the wall. So if you want to fix a wall, you need some tools, but you got to order the tools because you kind of don't get born with tools. So this is what it does. It just downloads all the tools you need, aka the libraries, and it's done running the code. I'll talk about that afterwards. So now these are the libraries we're going to use, pretty much like the toolkits, right? Like a box of tools is what each of these imports is. Import pandas as PD. We're just gonna call this toolbox PD, but it's really called pandas. But PD for short, because you don't want to write pandas each time you want to talk about the toolbox. So it's kind of like when people say, "How was your day?" Good. You don't say, "Oh, my day was really well," right? You just say "good" to just shorten your response. It's kind of like that. Import torch, which is aka PyTorch. PyTorch and torch are the same thing. From transformers. Download all these things, yada yada. So all this import stuff is just importing all the tools you need to fine tune the model, right? Screwdrivers, shovels, all that jazz. Next, it checks GPU if GPU is available, else CPU. Pretty much a GPU is what's used to train a lot of these models, but CPU can be used to train them as well. All it is like the chip, like GPU is like the graphics card, and CPU is most other information goes through CPU essentially. So it's pretty much the chip that's being used to train the model. Preferably GPU is preferred, but if you don't have one, it'll use CPU. That's all it's saying. CUDA is talking about the NVIDIA GPU chip, but that's all you need to know is that AI models are normally trained on that graphics card chip, or if it doesn't have that, then you can use CPU, which is computers. Everything you're seeing right now is probably CPU if it's not a graphic, it's not a visual thing, right? Next is this will create a function that loads the model, right? This will load the data, so not load the model, loads the data, right? Loads that CSV, loads the Excel sheet essentially. Well, I'll say CSV for now so I don't confuse you guys. But it loads that table from earlier. It loads this table into the code, right? So now the code environment has the file in there, That's what this does. If you didn't want to download that file, it just kind of creates that file, kind of like here essentially, not really, but this is just another option to create it manually. But this is a lot of work, and then you'll get lost on what's what. Like pretty much how this works, this part works, but it's commented out, so it's not going to do anything to the code. So if you want to switch it, it's the thing I did earlier for making this the comment version and uncommenting this. But it's like baked chicken, healthy. Baked chicken again. Sorry about that. Healthy. Fresh apples. Healthy. So that's kind of like how it goes. I mean, it's down, but you get the idea. Cool. Yeah, and then return df. Pretty much this function just creates this table in the code, right? Format data for GPT. So this function pretty much does that preparing thing and prepares the data for GPT to learn. So instead of giving GPT a book, be like, hey, read this book, you give it flashcards. You're like, hey, here's some little notes to learn, right? It's kind of like what you're doing. You're preparing it, the material for it to learn in an easier to understand way, or something that fits its formatting, right? Imagine I gave you a scrolls to study. You'd be very confused on how to read scrolls. You prefer books. That's like the idea. Instead of giving you scrolls, I give you books because you're used to learning from books. Next, this loads the data. So first one kind of puts the data into the code. Now we load the data for the model to touch it. Format data. You format the data. So remember before in video number, I forget which video was. When I was teaching you guys about functions, this is creating those guns. The df is creating the guns, and now we're using those guns, right? Cool, because we made this function earlier. Now we're using those guns. But reference my previous videos. If you haven't seen those previous videos I've done in the series, that will explain things a lot smoother. And now we're going to split the data. So when fine-tuning AI models and training AI, you split your data into training, test, and validation sets. So if I have like a bunch of cards, essentially, if I have a bunch of cards, right, all these cards, and this is my data. And let's say each card is a row of data, right? And this is the card, right? You would get some of it to train the model, some of it to test it to see if it knows what it's doing, and the rest of it you would use to like test it again to be like, oh, do you really know this? You know what I'm saying? In case they did a really good job on accident. That's pretty much. Let's throw these cards here. That's pretty much what happens here. You split the data into different chunks, right, or different sets. Now model initialize tokenizer and model. So this is where we choose our model. Our base model is GPT-2. So we're just summoning that model. Like we're to OpenAI. Hey, let us use GPT-2 to fine tune. Cool. So you get your own version of ChatGPT pretty much, and you load it into this code. Cool. So now this code. Now you got a bunch of things in this code. So you got the data that's been chopped up, sliced, and formatted, right? And now you have the model that's gonna be given that information. Cool. Padding. Oh, how do I explain this? I'm going to skip on padding for now. It's something to do with the text. The way the text is formatted. We'll get into that differently. Just add the padding for now. It doesn't hurt. Tokenize the data. Okay, so models don't speak English actually. They actually speak in numbers. Like computers speak in numbers. So it's pretty much the tokenizer is pretty much creating a translator for human English to computer number English, if that makes sense. It's just translating everything we're saying in we're translating all these words into values that the computer understands essentially, right? That's kind of what's going on with the tokenizer. Create data sets. I already said this. This is the training and validation set. Tokenized data sets. We're translating the data sets now so that AI understands. And remember, the DF is creating that gun, and now we're using the gun. Okay. Yeah. If you see a DF, that means we made something, and we're gonna use it later. Cool. Now data collector for language modeling. Oh wait, collator. This is getting too nitty gritty. This is just because GPT is an auto regression model, but we're gonna pass this for now. Like, don't worry about it for now. Training arguments. This is essentially like when you go to a basketball game or a soccer game or a tennis game or a video game or you go to a concert. the stadium, the field, the classroom, it's structured in a certain way for you to learn, right? You're not gonna learn with a bunch of fire around you, right? You're gonna learn probably in a quiet area, rooms closed off, people can't come in, there's lights and stuff like that. This is kind of what this is. It's setting up the environment, the rules of what's gonna happen for the training process. I'm not gonna get too crazy on these numbers. I'll teach that down into a later video in the series on the nitty gritty of the parameters of training, but just leave this the way it is. Don't change nothing. Initialize trainer. Kind of like the teacher is here now that's going to teach the model the information that you chopped up and prepared. That's what this does. Start training. You just start the training sequence, like start the study session. And that's all that running, like when it was training and doing all that cool green, blue stuff, that was this, right? Save the fine-tuned model. Once it's done being trained, it's going to save the model into a file, right? And that file is going to be here. It's going to be GPT-2 food classifier final, and then GPT food classifier, right? So this is so this is the model, and this is the tokenizer for that model, right? Which is like the translation, okay? Long story short, these are the files you need to run the model. These two files you need to run and use the model now, the one that you trained. Cool. So that's what this does. So this saves it, and once you leave Google Colab and come back, this won't be here anymore, just so you guys know, okay? But I put instructions in the code for you to download these on your PC if you want to keep using them and upload them and whatever you want to do with them, okay? But it's when you run the code, it'll tell you all that stuff. Now we're making a new gun, aka a new function that is called test model. And we're going to use that later. This is pretty much how we're going to test it. Remember the card thing I used to explain? Now we're going to test the model that's been trained to see how it's doing, and we're going to get an accuracy score, right? Like, how'd you do on this test? So we're going to test it. Test foods. So we're going to test it using these words right here, see how it does, and then you'll see it, talk to it too for food try. Okay. Evaluate. That calculates the score pretty much. And calculating the score, and this is just a bunch of print statements telling you how to download the files. Cause you can go here and I want to just download this whole thing. Yeah. Oh, you have to download like this manually one by one. Dang, that kind of sucks. It's probably a better way to download all this stuff, but yeah, you're gonna have to download each file one by one and create the folder yourself. Okay, well, that is cool. But the instructions are inside the code itself. So when you're done training, when you scroll down here, you'll see that it did the testing. It tells you what it was doing essentially, and then accuracy 69%, pretty much 70%. So it got 9 out of 13 correct. And then now here are those instructions. Sorry, I'm scrolling around. Here are those instructions on downloading everything you need. So it actually gives you a command to download the whole file, which is really cool. So there you go. Bet. So yeah, sorry guys, I've been doing a bunch of projects, so my code's kind of everywhere. I apologize, but everything's there for you guys to use. Cool. So now that you have the model ready, now you want to use the model, but be like, hey, how do I use this model now that I fine-tuned it? I got you guys. So remember I told you make sure that path is the same as this, which it should be. Now you're just going to run this, okay? To run it, you just click the cell. So make sure you're in the second cell. We're past the training. Just click anywhere here. Click on this. Scroll down. And you shall see it's downloading a bunch of stuff. Just to make sure you have everything. Of course, once you have everything, you can kind of remove that code of downloading things each time you run it. But for now, just to have you guys quickly start making stuff, I have it ready for y'all. Let me scroll down here. Cool. So it got grilled chicken is unhealthy. That's incorrect. French fries, unhealthy. That's correct. Quinoa is unhealthy. This is all wrong. But hey, it's okay. We can fine tune it again and add more epoch on that stuff later. But I just want to show you what the process looks like. We'll make this better in a different video. Just exposing you guys to the process. So if I say like pie, unhealthy. If I say chicken, unhealthy. You might call everything unhealthy. If I say popcorn, unhealthy. And this is a situation when you have to refine tune the model with a better situation, right? Maybe train it longer. It needs more data, possibly. Most likely, it needs more data. But in a video down the line in the series, I'm gonna explain how to make this actually work properly, how to fix it. You know, how to like troubleshoot the situation, right? But the model works per se, but it's doing really, really bad. Okay, so let me try fine tuning it again and see if it does better. Oh, actually, before I fine tune again, stop the code by pressing this stop button, and I'm just gonna fine tune it again. So I'm gonna just run it again. The original code. Should I add more epoch? I'm not gonna add more epoch. I'm just gonna run it again because earlier it was working just fine. And it's the thing with training these models. The first time you train it probably won't be its best version, just so you guys know. So I'm gonna run this again and retrain it from scratch. I'll come back with the retrain one. Actually, in the meantime, while it's retraining, I'm gonna show y'all in PyCharm how to do this. So open up PyCharm. You should probably get some main thing or whatever. Go to File, New, Python. I'm just gonna call it fine tune practice. Call it whatever you want. Then I'm gonna copy and paste the code from earlier, like I mentioned. It's still training, so I'm gonna copy this training code over here. Control A, Control C, go to PyCharm, click Control V, it should be here. And I'm going to pip install this, get rid of this. And what you're gonna do instead is, I'll show you guys exactly what to do. You're gonna go here to the terminal, click on that. Cool. Pip install, and each is you're gonna type each name. So transformers is the first one. Transformers. Then space datasets. Then torch. Then accelerate. Then want B, and then hit enter. And now it's going to pip install all these things on your PC just like it was doing in the other one. Okay. But now it's going to be on your local PC. Okay. Cool. So I'm going to let that do its thing. Okay, there's some incompatibilities, but it should still work. I'm gonna let this blue thing do its thing. So after you pip install, make sure the blue thing over here, like the blue bar, is done. And the training should be done. Oh, it's not done yet. Okay, cool. So back to the code. So now we're gonna delete all this, and you should be able to run this training now on your local PC. So, oh, not bad. Oop, you need that file. To upload a file, I would recommend you right-click this. You go to Open and Explore. Where is this file? Python project? Cool. Yeah, so you find that name of the project, which is Python project. Whatever you named it, it should be there. Now you need to put that file in here because it's not already in here. So I would say open up another window. I will hold the Windows key and press E. I'll go to Downloads. I'll grab this. I'll copy it. Close this. Click here. Paste it. Right click. Paste it. And now that data is in here. And if you want the path, you click on this. You hold Shift. Right click. And then you click Copy as Path. Close that, and then the path from earlier, you want to change that path. It's right here. This right here, the PD read CSV. Highlight this, Control V, put that path in here, okay? And get rid of like these question marks. Backspace, question marks. Cool. It should work. And just to make sure it works, put up the letter R in front of this, and this should work, okay? That's the only really big change you got to do. It's still training, which is, let me go to the bottom of this. But yeah, usually when you're fine-tuning a model, yeah, like I said, the first time probably won't be the last time you're going to fine-tune it. You're going to probably fine-tune it quite a few times. You'll tweak a couple things. Big chicken, healthy. Fast grilled salmon, unhealthy. This one's doing a lot better than before. and I'm unhealthy. Yeah. Oh, it's done training. Cool. This model's done training. It automatically goes to this folder. Now we're gonna run this code again. So we click here, run this. It's at the bottom. Scroll to the bottom. Where is it? It's loading everything. Cool. Testing multiple foods, checking healthy. Cool. And as you can see, it's still doing really bad. So that means I need to go into code and fix something to make this work better. I'll do that in a different video. But for you, this might work potentially. Maybe it might not work. It depends on the situation. Because when I first did it earlier before I started recording, it worked just fine. Now it's not working just fine. And that's the nature of AI. It's going to work sometimes, not going to work sometimes. Because AI is very random. People don't realize it's a very random process. But you're learning now. You see with your own eyes a real situation of training a model and it didn't come out well. In a different video, I'll go over how to make it work better. Cool. So now, to make this code work, I'm going to show you. So now that we have everything loaded, it should work. So I'm going to right click, hit run, and it should start training. Just to make sure I show you guys how to do it on both PyCharm and how to do it on Google Colab. And remember when I warned you guys in video 1, 2, or 3, in the earlier videos, I warned you guys about training on your local PC these big models. It takes time if your GPU is not that good. Because this PC GPU is like in the 1000 series, which is pretty bad compared to the 4000, 3000 series. So, but as you see, the code's running. There's no errors, so I know it works. But it's going to take some time to do its thing. And I'm not going to sit here and wait for you guys to watch me get it working. I'm just going to show you how to run the inference code, the other code. So you're going to open up another file, hit new, Python. We'll call it testing the model, right? Oh, setup failed. 16. Line 118. 1 second. Line 188. Oh, I see what's going on here. I see what's going on. My PyCharm is misconfigured. Sorry guys, I had an issue because in PyCharm it's viewing this test model. Well, it's viewing the test model as like a specific special PyCharm command. I changed it all to run model. So find the test model. Well, in the code you guys will get, it won't have this problem. I'm fixing it right now. And you can see now it's training. Yeah, once I fix that little error of the using test model function name is not a good idea. I just called it run model instead. And now it's training. So now you're watching it train, okay? Cool. Once it's done training, you see something like this. And yeah, I definitely know why it's not working well. I'm only training on a few epoch and not a lot of data, so probably it's more of the data, but we'll go into that later. Cool. And now the testing model code, we're going to grab that from the other thing. Let's go Colab. Yeah. So we're going to grab the testing code. So I'm going to hit Control A, Control C, place that into testing the model. We already made this file. Control V. Cool. Now we want to test it. Why is it freaking out? Why is it freaking out? It's at the top. Cool. This stuff. We can delete this stuff right here. Delete that. And this should. And then look for any other errors. No, there should be no errors. No. Alright, this one, I gotta change this right now. Yeah, Control F. 1 second. Alright, that should have fixed the problem. It's that word testing. Cool, right clicked, ran it, and now we're gonna see it do its thing, which is not doing well. Click here, type in apple, enter, unhealthy, pie unhealthy. Cool. So the model's not doing well, but this is really good. This is really, really good. In another video, we're gonna focus on fixing this problem now. So now when you have problems, you'll know how to fix it yourself. But cool. So that's pretty much it for this video, you guys. I know it was a long one, but there was a lot to learn. Because fine-tuning is a really powerful process that you really need to know if you're going to get into AI engineering or you want to know about the AI space. It's just part of it. Also, if you want to leave this, just click here and hit escape. Oh, sorry, hit escape. I lied. Wrong IDE. Click this red button on top here. My bad. There you go. That's how you stop it. Apologize for that. But yes, guys, appreciate you guys for tuning in. If you have any questions, please comment below. And remember, if you want to learn AI one-on-one with someone like me, an experienced AI programmer, I've been programming AI for 7 years now. I've been in the data space, in the statistics space as well. So I teach one-on-one students, groups. I teach the entire departments. I can make stuff for you. I can make AI models for you. I can make apps for you. I can make automation cycles. I can help you integrate a model into your current system. If you need any of that, reach out to me. My email linked below in the description of this video. But that's pretty much it for this video, guys. I really appreciate it. Peace.